So welcome, we are the AID FeatureScript team. I'm Matthew.
I'm Ashley.
And I'm Maythree.
So what is FeatureScript? FeatureScript is a software that writes code and automates and optimizes the geometry of an avocado plant. An example of it being used is shown here. The code is modular and calculates plant component dimensions, and FeatureScript is a relatively new programming language that is part of the Onshape platform, but we find many uses for it. So using FeatureScript, we can write code that can optimize and generate geometry. We can thus calculate plant dimensions and generate modular and scalable industrial infrastructure. So comparing FeatureScript and Onshape and how they interact, on the left is something being built in Onshape, and on the right is an example of a FeatureScript Feature Studio. Onshape is the CAD software used to design components of the plant, such as a flocculator. FeatureScript is a coding language for Onshape used to create custom features. It is created by clicking the plus button at the bottom left, where you see Part Studio and Feature Studio. Part Studio is where you will use CAD and build the object. And if you go into the Feature Studio, that is where you can input your FeatureScript code. So there are two main pieces of FeatureScript code. The first is a precondition in the first set of brackets, which is a user interface where preconditions and parameters are defined. The second part is a second set of brackets, where the function's actions, which define how the function regenerates, are. If you look at the Part Studio on the left, an extrude on the wheel rim is highlighted in yellow. Each feature given to us by Onshape, such as extrude, revolve, or sweep, it has code to make it work. Now let's take a quick look at the extrude code. These next couple of slides contain some code, but I'm just going to highlight the main important parts of it. So this is an example of the extrude FeatureScript code. It contains a header giving a brief explanation of what the code does, although the full header is much longer. And if you look, this part is part of the precondition, where the parameters like the domain are defined, where it says definition.domain is operation domain. And it is used in an if-else statement where it is compared to operation domain.flat. This next part jumps down in the code a little bit, past all the preconditions to the function's actions. It describes the function's actions and how the code regenerates. Here, if the body type is a solid, the constants, like the model entities, are given a value. Then there is another series of if-else statements which determine what the function should be depending on certain Boolean values.
This semester, the AID FeatureScript team has worked on several projects. The first things we have done have been updating existing FeatureScript code and adding units to implement hydraulic calculations, such as the ideal gas law you see below. Currently, we are also working on the test helpers feature. This is the code I did to define units in FeatureScript. Specifically, I defined the mole unit. I created a constant equal to 1 mole and plugged it into other units, such as Avogadro's constant, to make sure it worked. I also had to add a predicate to allow FeatureScript to check whether a value was a mole or not, which you can see in the function on the right. With this code, we can now implement hydraulic calculations in our features like the density gas equation. I also integrated the pipeline feature with existing components. In the past, certain components of the plant referred to an old outdated pipeline feature. We have recently updated the references so that all parts refer to the new pipeline feature. And this will allow our model of the plant in the future to use the code we've improved on the most. In addition to updating the existing code, we've also added a new tester feature. This tester feature will hopefully be open source so that people on the Onshape forum will be able to contribute and give feedback on the code. The module mainly contains functions that help with testing for the FeatureScript code, and Maythree will go into more detail about this later in the presentation. To go into a bit more detail about test helpers, we have decided to move test helpers into its own document to make it an open source feature. Then we plan on advertising this on the Onshape forums so that other people can contribute to the code and give us feedback on it.
To continue with what Ashley was saying, we started with like moving test helpers and also moving the compare maps feature to a different on-shape document. What was our plan of action? Our plan of action was fourfold: move, protect, post, and extend. So the first idea is to move it to a new public FeatureScript document outside of Agua Clara core FeatureScript. The next idea is to add branch protections to this Onshape document. The third step post is to post it on an Onshape forum so that other locations and people in other locations can share the functionality and edit it. The final fold is extend, which means that we extend the functionality to include other tests and like for failing the range checks of core FeatureScript. What are our achievements this semester? Part one has already been discussed in the mid-semester symposium. It's about merge, document, print, and abstract. We merged the test helpers with the tester feature and removed all import errors so that it was seamless. We documented it, or we added documentation to make it more readable. We added suppress printing functionality to make sure that our part studio is not cluttered. And finally, we added a layer of abstraction by converting constants and magic numbers to an enum. Achievements part two, what we've done since the mid-semester symposium. We've performed format, test, and move. We tried testing and formatting nested maps in compared maps. So nested maps are dictionaries within dictionaries. It was part of what Fletcher had implemented, like wanted us to implement. So, and it was working and passing the 5 case test suite we made earlier, which included empty dictionaries, equal dictionaries, not equal dictionaries, and nested dictionaries. The next step was to add additional test cases to the tester features. I already discussed the ones we had. The final thing was to move it. So we moved compare maps to different Onshape studio, and unfortunately that broke something. We're still working on fixing that. Before moving, it was like passing all the test cases. So we have some additional debugging to do like after the move stage, basically. Our future goals. We are going to finish up the steps in the action plan, or work on open sourcing the tester feature. We've already finished writing the range tests, and we are making sure the 3-level design works perfectly. So now it's demo time. Monitoring the part studio means running all the functions in the FeatureScript part studio and seeing if there are errors thrown. If not, then all the geometry regenerates perfectly in the design part studio. We have made active progress from our last checkpoint, and now there are no FeatureScript notices being generated on monitoring a part studio. We've also accomplished our goals from the last presentation that deal with testing all the functions. So let's go to our demo. So in our demo, we're gonna start with adding an arithmetic test feature. And when we instantiate the feature, we first see that on monitoring the arithmetic tests to part studio, we noticed that like arithmetic tests completed successfully and regeneration and error tests completed successfully. That means that the arithmetic test suite and the error test suite has passed all the test cases. Let's investigate. Let's try failing a test now. So if we look at the code over here, like this tests the addition function, and 1 plus 1 is supposed to return 2. And 1.1 plus 1.1 is supposed to return 2.2. But let's make this 2.3, and let's make this -1 just to see what happens. And then suppose we like compile this, and then after that, if we go to arithmetic tests, we notice that arithmetic test 1 and arithmetic test 2 fail. And then when we try to monitor the part studio, we notice this error message that says that arithmetic tests failed in the following cases. Floating point addition failed with message 2.3 is the result and the actual result is 2.2. So 1.1 plus 1.1 is 2.2, but we made the expected value 2.3 and we see that the test case failed. Divide by 0 results in infinity, and we change it so that it's -1. And thus we observe that dividing by 0 and like adding, if we change the expected output, we see how we could fail a test case, and thus by like thus we can test out different functions and see and make sure that our test your feature works correctly. Um, for any questions and recommendations, feel free to hit us up. I'm Moitri Chatterjee. This is my email. This is the email and for Ashley, and this is the email ID for Matthew. Feel free to address any questions for us. Thank you.
Thank you.
Thank you.